Assalamu alaikum students. As we have earlier studied about the matter and its three states and the states interchanging into each other at different temperatures and pressures. So these change of states can be explained in the terms of graphs also. Now these graphs are called heating and cooling curves. These curves are plots of temperature against time. These curves have same shape except they go in opposite direction. In each curve you will see flat sections. These indicate change of state. The lower flat section shows melting and the higher shows boiling. Flat sections show constant temperature because the heat provided is used for change of state. Now as this diagram mentioned below, I have drawn this curve. This is called heating curve of water. We can see the three levels over here from A to B, B to C, C to D, D to E and E to F. From A to B it is ice, and at B you can see at 0 degrees centigrade, B to C, the temperature remains constant, and this shows that ice is melting. Both the two states, solid and liquid, are present there. Now we come to C to D. It is now only one state, that is water, and you can see the temperature rising. At 100 degrees centigrade, it again becomes leveled, which means temperature is constant. That is from D to E, water is boiling. Both liquid and gas, both the states are present over there. That is, change of state is being taking place. Water is changing into from liquid state to gas. Then from E to F, now it's only steam. You can keep on rising the temperature, but it will remain steam. Now let's see another graph. This graph is a cooling curve of water. You can see its shape is changed. It is coming from top to bottom. We can see again the temperatures 100 and 0. F to E it shows steam. Then from E to D it is again constant, which is change of state. It is steam condensing, that is from gas to liquid. Now from D to C it's water, only one state. It's being cooled down. Now as the temperature keeps on cooling, the particles, they lose energy and they come closer to each other. At 0 degrees centigrade, water starts freezing, and so C to B, you can keep on decreasing the temperature. Temperature will remain 0 degrees centigrade till all the water changes into ice, and then it can drop and it will remain as ice. From B to A, you can see it's only ice. So this was the cooling curve of water. Now this is very important, these two curves. During exams, they can ask to different levels, that is what is happening at C to B, what is happening at E to D, why the temperature is constant and it's not being decreased or increased. So you should know that in the heating curve, it is constant because the particles are gaining energy and they are using that energy to overcome the attractive forces and change into from that is solid to liquid and then from liquid to gas. And opposite happens in the cooling. When you are decreasing the temperature, particles keep on losing their energy, they come closer to each other and the attractive forces start playing their part. It changes from gas to liquid and then from liquid to solid. This is all about the cooling temperatures, cooling of water. Now we have another topic, that is diffusion. Now diffusion, it is the random movement of the particles from higher concentration to lower concentration. Once particles mix together, they do not stop but keep moving at equal rates. For example, if you put a drop of ink in water, you can see it spreading. After some time, the water shows same color all over and you cannot observe the movement, but in real, particles of ink and water are moving at the same rate, so do not show any more color change. Now we have drawn simple diagrams to show. The first diagram it shows is that is the diffusion of gas into gas. These are the two test tubes which are placed one upon each other. The above one have air and the lower one has reddish brown bromine gas. Now the second one, You will remove the lid from in the center, and you can see that now the both jars have the same color. They may be jars, they may be test tubes, whatever you can take. You can say these are the jars. Now second one is between liquid and liquid. In one jar we have ink and water, and now after some time you can see that ink has spread all over into the jar. The third one is solid and liquid. There is first jar we have crystal of potassium permanganate and water. Crystal of potassium permanganate is solid. As we are saying crystal, it's of purple color. Now when after some time it will start dissolving and the solution will change all over the same color and it will have the purple color throughout. Now rate of diffusion. This depends upon the molecular mass, temperature, state of matter. Molecular mass, heavy particles move slowly, lighter particles move faster. Temperature, particles move faster at higher temperature or as temperature increases. Temperature increases the kinetic energy which is related to movement. State of matter, gases diffuse quickly as compared to liquid. Now this is a simple equation. Carbon dioxide, its molecular mass is 44 gram. Hydrogen, its molecular mass is 2 gram. If you compare their movement, you will see that carbon dioxide will diffuse very slowly as compared to hydrogen gas because carbon dioxide is much denser than hydrogen gas. I hope you have understood up till now. Thank you.
Hello. Well, this was our lecture for today. I hope you enjoyed it. Like and subscribe for updates from our channel. Take care.